All right, so put up the phones and the earphones and the earbuds.
No, probably not.
And Jordan and his brother.
So I don't know if you can see, so put up the phones and the earbuds and stuff. So over here, I went ahead and I kind of said a few things. Today we're gonna finish up Mars and maybe do Jupiter. We need to do gas giants and Jovian moons. The other thing in Unit 2 is a set of energies we call electromagnetic radiation. When you talk about light and all that, that's part of Unit 2, and then we'll talk about telescopes. So that's kind of a bird's eye view. Unit 2 exam, I would really like to have it before midterm, but that would put us at Wednesday, a week from Wednesday. So I'm just not quite sure. I know, right? So we'll see. I use the word tentative. We all know what the word tentative means. It means we'll try. We'll see. It won't be any earlier than that. If it's later than that, it's going to have to. Do you guys know that on, let's see, that's the 17th. On the 19th, which is a Friday, there's no classes because we have like a teacher in service day, which, but could be worse. So if it's not that Wednesday, it's going to have to be the following Monday or Wednesday. And I don't know. I kind of usually like to get 2 exams in before midterm. So we'll pick up, oh, by the way, then down here, a week from tomorrow is our second, or is for sure a lab. A week from tomorrow is for sure a lab. Right now, the skies look like they might be clear a week from Tuesday, but that long-term forecast, who knows? Remember the way this works, since this is our secondary date, even if it's cloudy, we'll meet and do something, okay? So mark your calendars. I am making arrangements to get binoculars from the West Burlington place, so school, campus. So I will have a set of 6 binoculars in case you don't have your own to check out. Because I know, like I had talked to Naya about borrowing a pair of binoculars. Remember, if you have a pair of binoculars and you have the moon, you can knock out a lab. For the labs, though, that you do, make sure when you write them up to look at what I'm looking for in the criteria. That's any class. You need to look at what the instructor said they want. Okay? So that's a possibility. But I've never done this before with binoculars. My husband's like, are you sure you want to do that? But because I have like loaned textbooks before and never saw them. Because I just forgot. But I think what I'm going to do is have it like a receipt, like you'll sign something and it'll be 1 week. So you'll have to turn them in that 1 week later. All right. So what do we need to know about Mars? Well, we did this slide already, but what's the white part up here? What's the white part?
Ice.
It is ice, exactly. But it's not water ice. It's, what's the thing that we're worried about increasing temperatures? Carbon dioxide ice. Yep, carbon dioxide ice. Very good. So to me, the surface of Mars looks kind of similar to places on Earth. I think you guys might have had a question about why does it look so red? And actually, if you've ever had like a nail and it got wet and you let it sit around in the air and stuff, when it dries, it rusts. Exactly. That coating that it's on your nail, that's the same thing as this red stuff, powdery stuff on Mars. It's rust. And what causes for the nail to do that thing is the element iron. So what's the symbol for iron?
Oh.
That 2 letters.
Oh, it's
It is Fe. Yep, Fe is iron. So that's kind of what gives it the red color. So, have we ever landed on Mars?
yes.
Oh,
Have we ever landed? Have we? Not the America. Has America ever landed on Venus?
No.
No. Who has landed on Venus?
Russia.
Russia. Yes. Has anybody ever landed on Mercury? No. Got some cool pictures of it. So this is what Mars would look like. Again, you can kind of see the striations of sediment rock forming. Looks like a Grand Canyon, doesn't it? This is a crater with kind of, we decided this is kind of like windswept kind of dust and stuff in the crater. And this was the rock that from Mars that actually, let's see, we have a meteoroid is a space rock. A meteor is as it's falling through the Earth's atmosphere, and a meteorite is what you pick up, a rock, a space rock that something's like it made it through Earth's atmosphere. So this is a meteorite from Mars. And I kind of told you, like, how do you know that's from Mars? Well, it's the chemical composition that makes it. And these are kind of looking at, that's a relief map, I think. We looked at one of these on Venus, and the high regions are kind of whitish, it looks like, and then red, and then the low regions are blue. So what do these look like, these little 3 dots? Mountains. Look like they could be volcanoes. Yeah. And so there's, I think it might be here-ish. There's a big thing called Olympus Mons, like the Olympic Olympus Mons. That's right here. And then the Valles Marineris, the Marinus Valley, it's right here. So that's Olympus Mons. And we already got to the slide before. It's called a caldera, but we actually have calderas here on Earth too. It's just kind of a shield sort of structure associated with kind of volcanic activity. So it's dormant now. Is it very big?
Yes.
Yes. About the size of Missouri, this says. Here's that kind of break. It's near the equator. That's the Valles Marineris. Valles Marineris, or Mariners Valley. Okay. So landslides, kind of the dust kind of falling. Now, since Mars, the planet Mars is kind of under the microscope of people. We have rovers there, several rovers. We have orbiters, okay? Back in the 70s, we actually landed and we took like a soil sample, and they actually did like a little experiment back in the 70s, and they got real excited. This would be the Viking missions, and when they did their experiment, they're like, oh my gosh, there's life everywhere on Mars, or a signature of life everywhere on Mars.
How did they get the soil sample back to Earth?
Well, no, they didn't get it back to Earth. They actually, you send a robot, just like a robot today, you have a robot do things like robot do your dishes or something like that. And so they sent a robot with the chemicals that the robot could have access to. And so the robot did the swishing and adding and analyzing. Of course, with our eyes were through the robot. So yeah, they did it and it tested positive for life. But how does this work? The chemical that does the signature of life actually was it was a false positive, basically. And in fact, that false positive was a hyper sterilant. So like on Earth, I think it was hydrogen peroxide or akin to that, that with all of that on Mars, if all of that was on Earth would be sterile. That doesn't really support life. But anyway, it's a really busy place. It has been for a while. Again, you can kind of see the Martian terrain. You see the carbon dioxide, frozen carbon dioxide at the pole there. I mentioned Viking. We had a Viking 1 and Viking 2. Viking was the one where mix the chemicals, test the soil. Oh, what I started to say is this kind of reminds me, there's been times when like a rover will be watching something, and then you'll take another picture and like a rock has moved. But it's just kind of, sometimes it's like maybe melting water, or it's just, there's always an explanation for the rock moving. But people who are suspicious are like, oh, the rock moved. So I just think that's neat. These little swirlinesses, and actually I'm going to play you this short little video, come from a dust devil. Okay, so picture the sand, okay, like a uniform sand, and then picture what I'm going to show you coming spinning around kind of randomly, and that's what makes those tracks. Looks downright artistic, doesn't it? So wind erosion on Mars. Like we see wind erosion on Earth. This is looking at the North Pole down, and so that's that solid carbon dioxide. what's this one? Evaporating ice on Mars. Okay. Now, I don't know if you've run into the word sublimate before. Sublimate is when something goes from a solid and it evaporates into a gas. If you play around with dry ice, you get that chunk of dry ice, and you don't see it liquefy, you see it basically evaporate, yeah. And so this is showing you ice sublimating from left to right. I'm not sure if that's liquid ice or carbon dioxide ice. One of the things about Mars is that, and I can't remember if we saw it on the video that we watched. Sleep on me. Maybe you guys need to sit up if you're going to sleep. One of the things that we see on Mars is not only is there wind erosion, but there's liquid water erosion marks. Now, right now, there's no like running liquid water on Mars, but there has been in the past. So if you know what you're looking at, some of these kind of lines look like they were associated with running water. That one definitely, running water. Okay, running water. And this is one of the places where I said, you know, they'll take pictures and they'll see a rock move. Well, this is another way where they'll take pictures and I think this is maybe the type of structure I've seen in the news, where they see actually kind of these streaks moving. Evidence for water on Mars, kind of these streaky areas. Okay. This caption says for this one right here that this would have been evidence for mud that cracked and dried, making those structures. So historically, and the next slide talks about War of the Worlds, okay? But leading up to War of the Worlds, how many people seen the movie War of the Worlds? Is it like, didn't they make one with that Cruise, Tom Cruise, War of the Worlds? Come on, folk pop culture people. That would have been several years ago. But, so aside from that, with telescopes becoming more popular, this particular astronomer, Italian astronomer, I'm not going to butcher his name, but he would turn his telescope to Mars, and this is what he drew. Okay, so you're looking back at 1877. This is what he saw on Mars. Now, we looked at Mars the other day, did not see this. Okay, but now that we know a little bit about Mars, you can kind of see this was the dust that he saw. Okay, ice cap, pretty cool. Now, one of the things, and I think it kind of got out of hand from this particular astronomer, that he would call, he called these things channels. Okay, channels, they kind of look like little streaks. Okay, and it got translated, I think this is how it worked, from channels to something man-made, like canals, you know, like the Panama Canal, like something intelligent made this so water could flow on the planet Mars. Now, this is 1877. Of course, it's a little while before we're going to get our, we're going to land on it and all that. Okay, but it got people thinking, as you might imagine, that intelligent life would have had to have created those canals. So the thing about War of the Worlds is it was actually back in the 1938. And one of the things I hate about this story is we have an H.G. Wells who wrote the book, and then we have an Orson Welles, spelled differently, who actually, at the time in 1938, would go on and do these radio programs. Because you figure 1938, TV, not a whole lot on TV. 1938, what there was a following on radio. So he would do, you've probably seen these before, where they'd have like a cast of characters. Of course, you wouldn't have to dress up because you're on the radio, but they would actually read a story, okay? And so one of the stories that he did, that Orson Welles did, was H.G. Wells' book, War of the Worlds. The problem is he did it actually in a creepy time, Halloween, okay? So Halloween night, New York City, that's where he broadcast it from. And he had a cast of characters that came and basically talked about an invasion of Martians. Now, in his defense, before he started the presentation, he said, this is all fictional, what we're gonna do, it's not real. But then he proceeded to do like a newscaster, and that's what made sense, seemed so real, we are being invaded by Martians. Yes, it was a big, hairy deal. People panicked. So I just think that's funny. Big, hairy deal. Oh, do you see the face? Do you see the little face?
I don't like that.
You don't like what? That little face? It does look scary.
It looks fun.
And there were 2 Viking missions, and one of them did the little chemistry kit on the planet, and it took some pictures as it orbited. And so that looks like how we have sphinxes here to honor the dead and honor important people on Earth. Well, that looks like a little sphinx. But honestly, it was just kind of a random sort of dust sort of thing. Okay. So this actually was done later. So the Viking, it was the Mars Global Surveyor, and you can kind of see doesn't have the features that it had there. So Martian atmosphere, it is similar, I believe, in pressure to the Earth's, but it is heavy with carbon dioxide. Honestly, though, if you look at the Earth's atmosphere, it has evolved over time. Right now, right now, Earth's atmosphere is mostly nitrogen, 20% oxygen, and trace amount of carbon dioxide. It used to have a lot more carbon dioxide, but on Earth, the carbon dioxide actually dissolved in the oceans, and it's been used by sea critters ever since. But Mars, if we were going to terraform Mars, we'd have to fix the atmosphere. A little bit of water vapor in the atmosphere. And the Martian daytime sky would look like this. Now, since Mars has an atmosphere, the nighttime actually, though, the daytime sky would look like this. We said the daytime sky on the daytime sky on Mercury would be black skies with a little sun in the sky. Okay? If you don't have an atmosphere, you don't have this, what's called scattering. You have a pink color instead of a blue color on Mars. Again, looking down at the pole, this is October 1996, and this is March 1997. So what, 6 months apart or so? You can see it, that solid carbon dioxide is what we say subliming as it heats up. So from this slide, if I were to ask you, you can see the answer to my question on the slide, is Mars' axis of rotation tilted? Yes. It's kind of similar to Earth's. Earth's 23.5, Mars is 25. Dust devil in action. This would be like from one of the orbiters looking down at the dust devil. You can see the shadow that's cast. That's pretty darn cool. Okay, so does Mars have any moons? Yes, it has 2 moons, and here they are. Meet Phobos and meet Deimos. They don't look like moons. They look like rocks. They look like rocks. They look like asteroids. Looks like they've been beat up a little bit over time. Little pockmarks.
Are they 2 different colors? Or are they the same color?
No, they look like 2 different colors, just different chemical composition, I guess. That's a good question. So these, is this right? I think, I can't remember. I don't want to butcher this too bad, but I think, I'll double check. I think they orbit counterclockwise, but anyway. All right, so this is kind of hard to read, but another one of those like little chart things. So we've been talking about Mercury, Venus, Earth, and Mars. Starts with letter T. What do we call those planets? Terrestrial planets. You got it. Yep, terrestrial planets. We're going to switch gears now and talk about the gaseous planets, otherwise called the Jovians. Okay, and again, this is kind of hard to read. What did we say? What did we say about the temperature on Mercury?
Really hot and really cold.
Really hot and really cold. Daytime really hot, nighttime really cold. What about the temperature on Venus?
Is it really hot?
Really, yeah, really hot all the time, daytime and nighttime. What is it about Venus that holds its heat? Venus is hot. Well, what is it about that holds its heat in Venus?
All the things.
The gas, yep, the thick gas, it's carbon dioxide gas in Venus. Yeah. Let's see, a few slides ago, what did I say about the temperature on Mars? What did I say about the temperature on Mars? Can we see on the slide? Well, it's on this slide. Here, I'll go forward. Temperature on Mars, 160 to 280 Kelvin. How does that compare to Earth? Somewhere in there, yep. What's the lowest temperature you can have for K? 0, yep. Very good. All right, let's go on to Jupiter.
We're going on to what?
Jupiter.
Oh.
So this then, if you want to go ahead and get 11 out of 10 points, then you need to post to that section, which was, must have, yeah, 2 to C, I think, as in cat. Yep. 2 to C. Yep. Now ready for 2-3A. Does Jupiter, Jupiter. Does Jupiter have any moons?
Mm-hmm.
Does it have?
Yeah, a couple moons, don't they?
Has lots of moons. Yeah, Jupiter has lots of moons. And we'll talk about Jupiter's moons, but we're going to hold all the moons to after we talk about the gas giants. Do all the gas giants have moons?
Yeah.
Okay, we already kind of talked about this. I'll kind of draw your attention to Jupiter, Saturn, Uranus, Neptune. If you were going to try to pair them up, of these 4 gas giants, how would you pair them up?
Jupiter, Saturn, and Uranus. And
I would too. And to me, I would pair them up just like that. Almost it's the color that gives them away. And actually, the color is an indication of what they're made of. And we're going to see that that's kind of why. Does Jupiter spin on its axis of rotation? Do you remember this? Does it rotate?
yeah, don't go the other way though.
No, Venus does though.
Oh, okay.
Venus goes the other way. Jupiter spins, do you remember how fast? 10 hours, about 10 hours to complete one spin. And that's a honking lot of gas going around 10 hours. Yeah. Sometimes it makes it to the to my test, but does anybody know what that circle is on Jupiter? It's the great red spot.
That's the video.
The great red spot. But on Jupiter, can you see the bands? When we talk about, when we dive into Jupiter a little bit, we're going to see that they alternate. So one goes this way, it's clouds, it's gas, it's not solid. And the next one goes this way, you go up, it goes this way, next one goes this way.
Wow.
So I know, so they alternate.
That's pretty cool.
It is very cool. Can you see some bands on Saturn too?
Mm-hmm.
Yeah. See any banding, but I think it's there for so I'll ask kind of a general rhetorical question. So what do you think? Saturn clearly has rings. Does Jupiter have rings? Yep. Jupiter has rings. They're not very predominant, but they're there. And all of these, Uranus has rings and Neptune also has rings. So you said that Jupiter and Saturn were similar. So what we have here is Jupiter and Saturn kind of going down into their core. I kind of tease that actually we have gases. One thing about gases, if you take gas and you pressure it, you can take a gas and you can make those gas particles slow down, cram them together, and they will join to make a liquid. So here we have molecular gaseous hydrogen. We compress it as you get closer to, this is the core of the planet. It makes metallic hydrogen, and it liquefies. And then it solidifies here and into the ices, And then here we have the rocky core. So what I started to say is I kind of teased that all gas giants, Jupiter, Saturn, Uranus, Neptune, it's like they swallowed a little terrestrial planet. Give me my dummy. All right. So that's Jupiter, Saturn, here's Uranus and Neptune. And you can kind of see that they have different compositions a little bit. What is Uranus and Neptune missing that Jupiter and Saturn has? Metallic hydrogen, yep. So this is Jupiter and Saturn. Let's see. You kind of see the clouds at different levels. The reason, well, yeah. Why do you, well, I'll put it this way, I'll ask the form of a question. Like when we look out, if there's clouds up there, that is actually water that's liquid water. Now, in order to get a cloud, you need water to liquefy. And in order for water to liquefy, you need two things. You need a certain temperature, and you need to have the water vapor around there. But if the air is dry, you're not going to get any clouds. Okay? So temperature and accessibility to water vapor. So here we have at these different elevations, it gets hotter as you get closer to this is planet surface. This is the top of the clouds. So at these different levels, we have different compounds that are making clouds. So H2O, of course, that's water. NH4HS, that is ammonium hydrogen sulfide. And right here we have ammonium. So these different layers of clouds. Now this one, these are our blue guys. I'm going to go ahead and circle this. And actually, we're not going to talk about it today. We're supposed to talk about Jupiter, but right now I'm talking about all the gas giants. What color are Uranus and Neptune?
Blue.
They are blue. What makes them blue is this CH4. Anybody know what compound CH4 is?
Carbon and hydrogen, right?
Carbon and hydrogen. And that's actually methane. That is methane gas. That is what makes them blue. And these similar, what color would you say Jupiter and Saturn are?
Brown.
Kind of brown, orangish, beigeish. Then what makes them that color is these two compounds. Well, yeah. Actually, the NH3 is ammonia. That's a good guess, though. Ammonia. And then the NH4HS is ammonium hydrogen sulfate. Sulfide, excuse me. That's okay. And then the way these graphs work is, and it took me a minute to see the way these graphs work. Do you see where along the x-axis we have temperatures, and that goes for this line right here. So in other words, at the kind of the surface of the planet, we're looking at, we come down here, and you're at a temperature of a little over 100 Kelvin. So anyway. This one is talking about winds. And one of the things about winds, oops, sorry, go back. That's my word fastest. It didn't look like fastest. But Neptune actually has the fastest moons in our solar system. Fastest moons, fastest winds in our solar system. And I was looking at this, I'm like, that doesn't look like the fastest winds because look how this line right here, the reason it goes back and forth is because the winds travel different directions at different latitudes, like relative to the equator. So in the equator, it's traveling this way, and then at the poles, it's traveling this way. Do you know on Earth, do we have any winds that go this way and winds that go this way? We do. We have some prevailing winds that kind of take the Earth and break it up into 3 different zones in each hemisphere. But notice that here along the x-axis says how fast it is. So this has a scale of 300, this has a scale of 200, 300, and only 100. So as I was looking, I'm like, I know Neptune's got fastest winds, but this is a different scale, a smaller scale. So, fastest, and they kind of change. So do you guys see this? You guys told me Jupiter has all sorts of moons, and it does. Jupiter has 4 special moons, and I think we saw them the other day with the telescope. It's got a set of 4 moons that Galileo saw, so we call those collectively the Galilean moons. This is, which one is this one? This is one of the Galilean moons, and we'll talk about it in one of those last parts. This is Europa. That is Europa's shadow. So the way this works is the sun would be over here, kind of relative to that. The sun is lighting up the planet Jupiter because Jupiter doesn't glow. And then also we have Europa going between the sun and Jupiter, and it's casting a shadow. I think that is so cool. So what is this right here? Red spot, great red spot. And can you kind of see some of the, ooh, I didn't know you could do that. You can kind of see some of the squirrels and swirls. So I'm not sure which is which, but you have like the white going that way and the tan going this way, the white going that way, the tan going this way. So you can kind of see where they meet, where you can get some kind of activity going on. What's that? Wolf. So Jupiter, how would you say Jupiter is with regard to size in our solar system? Planets in our solar system? Large. It's the biggest, yeah. So it's 318 times more massive than the Earth, and we saw some of this on the video. It's 2.5 times more massive than all of the other, should be 7 planets in our solar system. It could hold, volume-wise, 1,300 Earths. So sometimes when we get to talking about other stars, we're going to see that 2/3 of the stars in the nighttime sky actually have a companion. So there was a set of 2 stars that were born in the same nebula. Like, you know, we talk about the solar system, our star being born in the solar nebula. So just take a bigger nebula and make 2 stars there. Well, Jupiter would have had to have been 75 times more massive to go ahead and become its own little star. So this is looking at Jupiter in radio waves. So one of the things we're going to talk about at the end of Unit 2 is looking at objects like Jupiter, not just with visible light, but with other different energies. This is kind of showing you how one of the experiments that NASA did was to go ahead and to take a probe and to send it through Jupiter's atmosphere and send back some good information. Close-up of Jupiter, beautiful. All of the gas giants are mostly hydrogen. So this great red spot that you would tell me, great red spot, it's been actually churning for over 350 years. Yep. Way back when, in 1664, it was spotted, no pun intended, and it's like a big old hurricane, which, oh, by the way, Hurricane Michael gonna hit Florida, the Panhandle this time, maybe Wednesday. So that bit about bands going both ways, like this way and that way and this way, that's called differential rotation of the bands of Jupiter. The different colors we see, the beautiful different colors we see in Jupiter is showing you actually different chemical compositions. Great red spot. Oops, sorry. Great red spot. And these things are ovals. Sometimes they join, and they're other storms. Sometimes they join and make big ovals. It's beautiful. Great red spot. That's all I got. Well, that's probably enough for today. So we just kind of, and again, the moons of Jupiter is coming up. Okay? Yay.
Bye-bye.
Well,